Alright, the start of a new chapter, lesson 10.1, and we are going to be playing with nets today. So first of all, you need to know what a net is. And a net is a two-dimensional pattern that can be folded into a three-dimensional figure, the three-dimensional figure being a polyhedron. Now I have this little video thing up so you can kind of see what it is. So here's my net. It's my two-dimensional shape. And then if I press play, it's going to fold in all of these pieces and it's going to become a shape. We kind of did this for our first project in geometry, but you can look at all the different ones. So here's our net for our triangular pyramid, and it folds up. Here's a milk carton, and all of the pieces fold in. So now we're going to go to the next page, and we're going to talk about a polyhedron. Now, these are all pictures of a polyhedron. And a polyhedron is a three-dimensional figure whose surfaces are polygons. And we already know what polygons are. Polygons are basically a shape that's not concave, and also it can't have any random lines going through it. So we have our triangular prism, our rectangular prism, our pentagonal prism. We have all of these different shapes. So the first thing we're going to do is talk about the parts of a polyhedron. So the parts of a polyhedron are these, main three parts. So we have a face, which is like the polygon. So like this rectangle here is a face, this rectangle here is a face, and so on. So in this picture we have 1, 2, 3, 4, 5, 6 faces because the ends are also faces. And then we have what's called the edge, and the edge seems very self-explanatory. It's where the two different shapes come together and make an edge. And then we have the vertex, just like in a triangle and a square. Our vertex is where we have 3 or more pieces meet. So first thing we're going to do is identifying the net. So the first one is we're going to talk about what this shape could be. If I fold in all of these pieces, so if I fold in the E and F, so then I would have a shape that has 4 boxes going this way, like this. It's not as good as my computer drawn 4 boxes, but we have my 4 boxes. And then we would have 2 pieces coming out and straight up here. And then we would fold in all of these other pieces, and you would hopefully say that this shape would make a cube. Now, when we look at a cube, we want to know the letters of the opposite faces. Opposite faces meaning across from. Just like when we made our polyhedrons at the beginning of the semester, you had to name the opposite faces. So in this case, E and F would fold up together. So E would be opposite of F. So E and F go with each other. And then if we fold up these two, we would have B and D that face each other. And then A is going to flop over the top, and it's going to end up being across from C. So then we're going to have A and C. So now we're going to do the opposite. We're given this, and we need to sketch the three-dimensional figure. Now, don't be so upset if you are not an awesome artist. Just do your best. So if I were to sketch this, I'm going to start by looking at what different shapes that I have to begin with. And I have triangles. So I'm going to start by drawing a triangle, like so. And then I'm going to draw another triangle right underneath it, just like if I were to draw a cube. And most of you have drawn cubes before. You draw the square, and then you draw another square right next to it, so then you can connect all these pieces and make a cube. We're going to do the same type of thing, except we have a triangle, and I'm going to draw another triangle underneath, like this. And then I'm just going to connect all of my vertices to make edges. And this is what my shape is going to look like. I have 3 rectangles, so 1 rectangle, 2 rectangle, 3 rectangle, and 2 triangle faces. So I have a triangle here and a triangle here. So this is what my three-dimensional shape would look like. So now I'm going to have you draw a net for this picture. And how we're going to do that is we're going to try to look at how many different sides we have and what the different shapes are. So if I'm looking at my Captain Crunch cereal box, I have a rectangle here. So I have this rectangle. Ooh, that was not good. Sorry. I have this rectangle here. I also have this one and this one, which are a little bit smaller, and then I have this outside edge over here and this one down here, and then I also have another triangle that looks just like this one in the back. So when I start drawing this, I'm going to draw my main face here. And remember, I'm drawing a net. So I'm drawing my rectangle here. And this is like the front of my box. So I have my Captain Crunch front. Okay, so then I have this side with the nutrition and the ingredients. So that side needs to come out because it's like I'm cutting it open and making it flat. So I have this side that comes out that says the ingredients, and then I also have the other side like this. And then I have a top and bottom that are both the same size as this width. So it's going to go up here like this, and then down here like this. Now it is a net and I have to have it all connected, and I still have the back piece. So what I'm thinking is I can either draw it right here and make it really wide, or I can draw it down here. And since I have space this way, I'm just going to draw my other, like the back of my cereal box down here. And this is the back. So I have the back, the top, the bottom, and the two sides. So this would be my net for my cereal box. Okay, now we're going to talk about a formula. It's called Euler's formula, and it's the number of faces, vertices, and edges of a polygon are related in the formula f plus v equals e plus 2. So our first example is going to be count the edges or faces and edges, then find the number of vertices in the polyhedron. Now when you're counting, I would suggest getting colored pencils and marking things off so you don't get lost. So for example, this is one face, and I marked it with a blue line, so I know I already counted it. 2 faces, 3, 4, 5, 6. So that's the outside. I have 6 faces, and then I have the top face, which is 7, and the bottom face, which is 8. So number of faces is 8. And then it also says to count the edges. So I'm going to change my color and say 1 edge, 2 edge, 3, 4, 5, 6. And then I have 7, 8, 9, 10, 11, 12. So I've done all the top and all the way around. And then I have 13, 14, 15, 16, 17, 18. So I have 18 edges. So now I can use my formula to figure out how many vertices I have. So I have faces plus vertices equals edges plus 2. So faces is 8. So I have 8 faces plus, we don't know how many vertices, so v equals my edges, which is 18, plus 2. So I have 8 plus v is equal to 18 plus 2, which is 20. And then I would subtract 8 from both sides. So I have my vertices is equal to 12. And now we can count our vertices to double check. And remember, our vertices are where we have our corners. So I have 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12. So I ended up with 12 vertices, which is what it told me by using Euler's formula. All right, that's it. I'll see you tomorrow ready for classwork.